the dimensions, the outer dimensions, outer width is capital B, and if inner width is small b, if outer depth is of capital D, let inner depth is of small d. Now, using this case, how to derive the section modulus? We should know the I and Wimax. Now, recall the fundamentals. What is the value of I for this one? Now, I is the moment of inertia of the hollow rectangular section. We know that I is equal to BD cube by 12, capital BD cube by 12 minus small bd cube by 12, and we arrived at 1 by 12 capital BD cube minus small bd cube. Let us come on this tabletop. For this particular rectangular section, the value of I is equal to, we know that for a full section is of 1 by 12 BD cube. We have to subtract this hollow part. So, minus sign 1 by 12 BD cube. So, if we are taken out 1 by 12, a common part out of that, then we achieve BD cube minus BD cube. So, the I value is of like this. Now, what is the location of Wimax in this particular figure? Given figure is of symmetrical. So, we have to plotted the neutral axis. This depth is of d by 2 and this depth is of d by 2. So, my Wimax is equal to d by 2. So, to achieve Z, I by Wimax is equal to 1 by 12 BD cube minus BD cube divide by d by 2. We got 1 by 6d bracket BD cube minus BD cube. This is the Z for a given rectangular, hollow rectangular section. Now, if a given section is hollow square section, think what you can do for hollow rectangular section. Let us try for hollow rectangular section. This part which has been cutted down, hollow square section. Let the outer dimensions are, if we narrated that one, then this is, I will say it is B, this is nothing but small b, and it is a given square section hollow. Then I is equal to 1 by 12 BD cube. Instead of, we have to go b raised to 4 minus b raised to 4. What is Wimax? It is b by 2. Therefore, Z is equal to I by Wimax is equal to 1 by 6b bracket b raised to 4 minus b raised to 4. I wish you got this point, that how to find out the section modulus for a simple section like rectangular section and square section. Now, let us go ahead with the next one. Circular section. How to find out for a circular section. Let's come on the tabletop. Now, circular section, solid circular section. So this is full solid circular section which has been given to us with diameter d. We have to find out z under question mark. What is the value of I? Recall the fundamentals of moment of inertia. The value of I for given section is pi by 64 d raised to 4. What is the value of Wimax? Now, center of gravity is over here, centered is over here. The line passing from this point is known as neutral axis. So, total depth is d. Then, this is our radius r. So, our Wimax is nothing but radius r of a given circular section, which is equal to d by 2. So, let us be transferred in the z. I by Wimax is equal to pi by 64 d raised to 4 divided by d by 2. We achieve pi by 32 d cube. So, for a given solid circular section, the equation for section modulus is pi by 32 d raised to 3 d cube. I think there is not a single question from your side. It is very easy to achieve the same thing which has been displayed on this particular PPT, that is z is equal to I by Wimax, that is pi by 64 d raised to 4 by d by 2. Here the small d which has been suggested as the diameter of solid circular section. We achieve pi by 32 d cube. Now next, Holo circular section. Let us plot over here the Holo circular section over here on this tabletop. Please come. The given section is of Holo circular section having outer dia is of capital D, inner dia is of small d. Now, if we take in this case, our intention is to find out z, that is the I by Wimax. What is the value of I in this case? This is equal to pi by 64 bracket d raised to 4 minus d raised to 4. This is the basic fundamental equation of moment of inertia of a given Holo circular section. What is Wimax? See, this diameter is d. The given section is of symmetrical section. The center of gravity, it is known to us. Neutral axis known to us. This value Wimax, which is nothing but d by 2, capital D by 2. So we got z is equal to pi by 64 d raised to 4 by d raised to 4 divide by d by 2. Then we got z is equal to pi by 32d bracket d raised to 4 minus d raised to 4 for Holo circular section. So we found out an equation z is equal to pi by 32d bracket capital D raised to 4 minus d raised to 4 for Holo circular section. So if we see in this PPT, the same equations that we got by simplifying an equation I by Wimax, that is pi by 32d capital D raised to 4 minus d raised to 4. Now let us we take a combination of rectangular section like a T sections and we see how to find out the value of z on this tabletop. So let us take a one simple section. Name of that section is to be called T section. The dimensions are 100 mm, 10 mm. This is once again 100 mm, 10 mm. Now, how to find out the section modulus for a given section? To find out the value of z, it is utmost important to find out the value of I and y max. Our basic fundamental formula z is equal to I by y max. So we have to both the find out value of I, we have to find out the value of y max. Up till now we have solved a simple rectangular section, square section, circular section, holo rectangular, holo square and holo circular section, for which we know the value of I easily, for which we can easily find out the centroid and we can easily find out the value of y. Should it possible over here? No, we have to find out those two things separately for a given section. So, to find out those things, it is at most important to find out the centroid of a given section. What is the location, the centroid for a given section? Please on the tabletop. Over here, how to find out this centroid? Let this is the CG or centroid and let this will be your neutral axis. Then this value is of y b. B means bottom. The distance of y from the neutral axis to the bottom fibers. How to find out yb? Let us we divide this T section into two parts. First rectangle, second rectangle. So yb is equal to a1 y1 plus a2 y2 divided by a1 plus a2. This is the basic equation to find out the centroid. So if we proceed further for the same, then yb is equal to what is a1? A1 is the area of first part, 100 into 10. What is y1? y1 is the distance of neutral axis of first to the bottom fiber, means From this point, if I will take the figure, please refer the figure, and if I will take the another color pen, this is the center CG. From this point to this point, this is my y1. What is that y1? Let us write over here that y1 is nothing but 10 by 2 plus 100. If we refer the figure, CG acting at half of that, 10 by 2 plus 100. Next, plus A2. What is A2? Area of second part, that is of 100 into 10 into once again y2. Let us take another colored pen so that we will understood better way. The CG of this second one acting over here, center, that from this point to this point, y2. Yes, suggest what is y2? Definitely it is 100 by 2 divided by A1 plus A2, area of first part plus area of second part. You have a calculator, you can solve very easily and find out the value of YB in terms of millimeter. Now, how to find out YT, how to find out Wimax, how to find out I, and how to find out Z, we will discuss into the next session. So, from the today's session, we understood the pure bending theory, we understood bending equation, that equation M over I is equal to F over Y is equal to E over R. We understood moment of resistance, M is equal to F into Z, and we have also found out the modulus of sections of different section. We will solve more numericals into the next session. Till now, please study more part from the book at your home. Find difficulty, ask the question. Thank you.